Corresponding is.
I put it in the same place on the diagram.
That's actually really, really good. Anybody else want to throw out their definition? Yes, ma'am. Very nice. Although that could be corresponding, consecutive. But I see where you're headed with it. I'm asking you this because thus far we've only used the word corresponding. We've only used that for that one situation, two lines cut by a transversal. Today, that is going to be a much broader thing for us. Today, we're going to be looking at congruence of triangles. Now, while you start up whatever notes you take, I'm going to come around and get your Dom.
If you want to,
Okay. Apply congruence and triangles. Here we go. First thing you need to know today. When a polygon is congruent, it's the same size, all the sides are the same, all the angles are the same. These are congruent trapezoids. You don't need to know trapezoids yet, but they're all congruent shapes. Notice, they're turned, but that's the only way that they're different from each other. They're turned, but they're all the same lengths of the sides, all the angles are the same. For shapes to be congruent, every angle has to correspond with another angle on the other one, and every side has to correspond. Now, here's that word correspond I was talking about, which means for every side, there has to be another side that's the exact same. For every angle, there has to be an angle that's the exact same. So, for instance, this side corresponds with this side, corresponds with this side. This one corresponds with this one, corresponds with this one, etc. These are not congruent, because even though they're all triangles, they're different shapes, different angles, different sizes. Sure. Good question. That is an excellent question, which I will address in just a second. People want to write any of that down. There aren't many notes today. I think only 3 slides worth. Don't quote me on that, but I think. Here's how. Do you need me to go back? Go back. One second. Okay. Now, here we go. These two triangles are congruent. Notice, we have a 1 dash side, a 1 dash side. 2 dashes, 2 dashes. 3 dashes, 3 dashes. 1 loop, 1 loop. 2 loops, 2 loops, 3 loops, 3 loops. Everywhere you see the same thing, those pieces are corresponding. You're right, they are congruent, and they correspond to the other shape. Now, these two are perfectly laid out right next to each other. They won't always be like that. What if that exact same shape was flipped over like that? Does that make it less congruent? No, it's just angled differently. Now, this side goes with this side, this one with this one with this one, etc. Now, a congruent statement. You're going to be asked to write congruent statements today. This is a congruent statement. Now, obviously, you don't have to color code it. The reason they color coded it is so that you could match up the pieces. Please look. A has 1 loop. F has 1 loop. B has 2 loops. E, 2 loops, etc. A, B, notice the first 2 letters have 1 dash. F, E, 1 dash. The important thing when you write a congruent statement is the order. A, B, C is not congruent to E, F, D, or D, E, F. It has to be F, E, D. The order has to match up with the corresponding pieces in order for your congruent statement to be accurate. Raise your hand if you have a question on that. Now you could write this any number of ways. You could do A, B, C, F, E, D. You could do B, C, A, E, B, F. You could do C, D, A, D, E, F, etc. As long as the pieces are corresponding in the order that you do it. Questions on that? I believe there are two theorems. I don't know that you need to write both of them. Yeah, you probably want to put this in your postulation theorems. You're probably going to use it. It's an extremely simple logic, but you probably are going to need to know a proof. The third angle theorem. Third angle theorem. Again, I'm sure if you thought about it, you could figure this out naturally anyway. Because all triangles add to 180. If two triangles share two common angles, guess what we know about the third angle? It has to be the same. Because, for instance, let's say this is 30 and this is 100. That means they both add up to 130, which means the last angles have to be what? 50, that's right. Because they all have to add up to 180. So it's an extremely simple logic problem, but yeah, somebody broke it, so I had to write another. Yeah. So anyway, third angle theorem. If two angles are corresponding and are equal, congruent, then the third one is congruent. On a future proof. On a future proof, you may have to say, prove that these two triangles are congruent. Well, if they tell you the two angles are, you can easily show the third angle is congruent by the third angle theorem, and that'll be part of the way. Because as of right now, the only way we can show triangles are congruent is to show all of their pieces are congruent. Hence how that's going to help you. You might need me to leave this up there for a moment. So yeah, we started getting that blizzard last night. I got excited. Like a few years ago, what did we get out? Like 13 days? The good old days. Alright. Now, this you do not have to write down because we've already talked about it, but I want you to be aware of it. Don't forget the transitive property. You may have to show that two triangles are congruent in the future, and all that it'll tell you is that, like, hey, ABC is congruent to DEF. DEF is congruent to JKL. Therefore, by the transitive property, if both of these are congruent to this one, then what are they with each other? That's just the transitive property. We've already talked about it, but that's just one more way we might use it. We're already ready for the examples. Now, the hint comes in the directions. These aren't going to line up. You may think these are the same thing right next to each other. They're not. They're flipped. You don't have to worry about eyeballing it. Look at the congruent statement. Which angle are we asked to find over here? Over here, what is the angle we are actually asked to find? A, B, C, D, E, F, G, H, I? I. We are asked to find angle I. Angle I corresponds to which angle in the other shape? D. See how they're both the fourth one? So this equals 47. You're going to have to look at the directions, and it'll tell you which pieces match up. No, A would be F. Okay, so here we go. 8y minus 9 equals 47 because I equals D. So add the 9, divide by 8, and y is 7. Now, AE is the first and last letter, so what corresponds to that over here? FJ. So therefore, these two pieces equal. 3x plus 4 equals 10. Two pieces equal, set them equal. Questions on that? Alright, subtract the 4, divide by 3, and x equals 2. Questions? This is the math today. All you have to do are find the pieces. Whoever has that laser, put it up. If I find out who has them, I take it. Okay. Here's another one. Oh, yes, sir. Please close it. Yeah. All right. Now, we're asked to find x. X is on what side? Somebody give me the two-letter whatever. F and D. Very good. What two letters go along with F and D? A and C. So therefore, what equals what?
9.
Very good. 9 equals 3x. Divide both sides by 3, and what does x equal? Muy bien. How are we going to find angle D? Or Y, I should say. D is congruent to what angle? A. The first one. The first one and the first one go together. D and A. So that's what? How would I set that up? Very good. That's very good. And y equals 5. That's the kind of thing you're going to have to do. Now, well, hold on. I won't get into that just yet. Let's see. Questions? Pretty sure it's just a whole bunch of that kind of thing. These are fun. Let's see. Number 5. Now this, they don't tell you a congruent statement. You have to figure some things out. How do we know which angle is congruent to x on number 5? It does. But it only tells us that one of the angles is congruent. How can we assume another angle? Yes, ma'am. Very good. Very good. These are vertical and are therefore congruent. See how this kind of forms a bow tie turned on its side? We're going to be looking at this bow tie shape a lot this semester. And every time we have it, there's going to be vertical angles that you can assume are congruent by the vertical angle theorem. So these are congruent, these are congruent, and the only other pieces left to be congruent are x and 65. That's the kind of logic you're going to need to be able to use. I'm not a big fan of assuming. If you're right, yay. If not, then you've been warned. How about that? Okay. Technically, we're done, but there's one other thing I want to show you real quick. Technically, we're done, but there's one more thing I want you to see. So just hold up. And I'll be passing out a worksheet.